Okay, we're going to solve the next exercise. Exercise is the number 1.26. A person weighs 180 pounds at sea level. The radius of the Earth is 3,960 miles. What force is exerted on the person by the gravitational attraction of the Earth if he is in a space station in orbit 200 miles above the surface of the Earth? Alright, down. I'm going to explain ESAP. The principal concepts that we have to take into account here in order to solve the exercise. The concepts are principally physics concepts. So if I have two particles separated by a specific distance, which I'm going to call it r, and this particle, I'm going to call the mass of this particle m1 and the mass of the second particle m2, there is going to be generated an attraction force between them, which is going to be equal for each one of them. So this force is equal to a constant g multiplied by the mass of the first particle multiplied by the mass of the second particle divided by the distance between them divided by 2. So after this is actually explained, what I'm going to do here is that I'm going to transform this force into a weight, because this weight is going to be given by this same equation. So now, because of Newton's second law, which is a force equal to a mass multiplied by an acceleration, then I'm going to change this part of the equation and transform it into this. A mass multiplied by an acceleration is equal to g multiplied by m1 multiplied by m2 divided by r2. Alright, when we're talking about the Earth, I'm sorry, that doesn't look like a sphere. Although the Earth is not spherical, we are going to assume that in order to get our results more like closer to the real result. So for a particle on the surface of the Earth at sea level, the distance between the center of the Earth, which is our mass 2, the Earth, and the particle, which is our m1, the radius of the Earth is going to be the distance between the two particles. Alright, now because of this, m multiplied by a is equal to g multiplied by the mass of the particle multiplied by the mass of the Earth divided by the radius of the Earth to the second power. Then this mass of the particle and this mass of the particle are the same, so I could send this mass dividing the other mass of the particle, and I could eliminate the result. So the acceleration is going to be equal to g multiplied by the mass of the Earth divided by the radius of the Earth to the second power. This is going to be the gravity acceleration, which is for the international system units 1.81 meters per square seconds, and for US customary base units is going to be equal to 32.2 feet divided by square seconds. Alright, now this g is given in a is given in a constant. So this constant is equal to 6.67 times 10 to the minus 11 newtons multiplied by m to the second power, which are meters, divided by kilograms to the second power. Now I could transform this expression, sorry, I'm pointing it, this expression to another one. So G multiplied by ME is going to be equal to G multiplied by the R of the Earth. I'm gonna call it RE to the second power. All right. So this G is this same G. Now let me play with the units for us to understand that they are going to be the same. The G is given in Newton multiplied by meter divided by kilograms to the second power. The mass of the Earth is given in kilograms. I am playing with these units in International System units, right? Because I am used to manage that kind of system. Then the G is going to be equal to mass divided by square seconds. I'm sorry, not mass, meters. Meters divided by square seconds multiplied by meters to the second power. Now this is going to be equal to meters to the third power divided by square seconds, and now I cannot do this. I cannot do anything else with this part of the equation, but now I will play with this and I'm going to write it on blue, I'm sorry. Then the Newton is a force. Because this is a force, it is equal to a mass multiplied by an acceleration. So this is equal to a kilogram multiplied by meter divided by square seconds multiplied by square meters, which are these ones, divided by kilograms to the second power. Then this is going to be equal to kilograms multiplied by meters to the third power divided by square seconds divided by kilograms to the second power, and those kilograms are divided by 1. Or actually I could assume that they are divided by 1. Then I just have to apply this law in which I multiply the numerator part of the first division, which is this one, with the denominator part of the second one, which is this one. So the answer is actually the same because I multiplied by 1. So the answer is kilograms multiplied by meters to the third power, and then the result of this second part is kilograms to the second power multiplied by square seconds. Then I could eliminate this I was checking, but I forgot to write down the others kilograms, these ones. Alright, so I'm going to write it down here, kilograms. Now I'm going to erase this because I've made a mistake here, sorry guys. Although I'm gonna keep this part of the video because not all exercises like are solved the way we want it, so we have to pay attention at what we're doing, and this is a clear example of that. Now I could eliminate these kilograms with this square, and I could eliminate these kilograms with these kilograms. Now the answer is given by meters divided by square seconds multiplied by meters to the second power. I'm sorry, and this is the same as having meters to the third power divided by square seconds, which are the same units of meters of this part of the equation. All right. Now that I've made that clear, I can continue with my assumption, which is acceleration is equal to g multiplied by re to the second power divided by r to the second power. Now, because of Newton's second law, which is a force equal to a mass multiplied by an acceleration, I'm going to transform this equation into these ones. So a weight is equal to a mass multiplied by g and multiplied by re to the second power divided by r to the second power. If you pay attention, or if you notice, what I did here is that I multiply by the mass, the part of the actually before the equal and after the equal. So a mass multiplied by a gravity is mass by gravity, and a mass multiplied by an acceleration in this case is a force, which is the weight. Alright, now I know that I said before that this r is equal to the radius of the earth, but this is in the case in which the particle is on the surface of the earth. But this exercise is telling me that this person is in a space station which is in orbit 200 miles above the surface of the earth. So this r is not necessarily the radius of the earth in this case, because if the person were on the surface of the earth, this is going to be the same values, and this part of the equation is going to be equal to 1. So the weight of the person is going to be equal to the mass multiplied by the gravity. But in this case, I gotta add the 200 miles to this part of the equation. Now, a person weighs 180 pounds at sea level. The radius of the earth is this one. What force is exerted on the person by the gravitational attraction of the earth if he is in a space station in orbit 200 miles above the surface of the earth? Now, they are asking me for the force, so they are asking me for this force. Alright, which is equal to this one. In this case, is the weight. We call it weight. Alright? Now, the answer is going to be equal to the mass multiplied by the gravity, which is the same weight. So, 180 multiplied by the radius of the earth, which is 3,960 miles, divided by the radius, the distance between the two particles, in this case the earth, the center of the earth, and this man or this person. So that is equal to 3,960 plus 200 miles. Now, I know that those miles or these miles are not the common used customary unit for when we are talking about length. So I could change the value by transforming those units into feet, and that is equal to 5,280, because 1 mile is equal to that. And I could do the same thing with the denominator part of the equation. So 1 mile. And then I'm going to transform that to feet, but as you can notice here, that is not necessary because I am multiplied by a value. I did it for you to analyze it, but that is not necessary. If I am multiplying a division, so this multiplication I am canceling with the multiplication that I'm doing on the denominator part of the division. So this is the same thing as doing nothing. So the answer is still the same, to 100, 3,960 divided by 3,960 plus 200, and this to the second power, which is the same thing as having the denominator part of the equation to the second power and the denominator part of the division to the second power. Now the answer is 180 times, let me open the parentheses here, 3,960 divided by 3,960 plus 200 to the second power. The answer is 163.1083. This is a weight, so this is pounds, force pounds in this case. Well, just forget it. I don't want to confuse you right now. Those are pounds. Now I wanna explain something else, and it is transforming these pounds into international system units for those who are more comfortable managing that kind of unit system. So they are talking, or I am talking actually, about a weight here. Now, because I have already explained this, but because this is a weight, this is equal to a mass multiplied by an acceleration. So in the US customary base units, when we are talking about a force, then we have to talk about a force pounds. When we talk on the international system units, when we talk about a force, we have to be talking about a Newton. Alright? Now, in the US customary base units, when we talk about a mass, we could talk about a slug or a pound. On the international system units, that is more easy to understand, because when we talk about a mass, we have to be talking just about a kilogram. Alright, now what is the difference between this one and this one? The difference is that this one is not being multiplied by an acceleration, which in this case is the gravity, but this one it is. Alright, in the international system units, we have also something called the force kilogram, which has actually the same explanation of this one. Is being multiplied by an acceleration, which in this case is the gravity, the 9.81 meters per square seconds, or the 32.2 feet per square seconds. Now, what I'm going to do here is that I'm going to transform those 163.1083 force pounds into the International System units, which are the newtons. Now, because this is a force pound, this is equal to a mass multiplied by an acceleration, which are these ones. Alright? And I'm going to transform those into newtons, which is the same thing as having a kilogram multiplied by meter divided by square seconds. Alright, now what I have to do, 83 slugs, is to multiply it by division. So I have to write down the equivalence. So 1 slug into kilograms. Now 1 feet into meters, and that's it. Why am I putting the slugs on the below part of the division? Because these slugs are on the upper side of the division, and for me to eliminate it, then I have to write it on the below part of the division. So I could do this and this. Now I just have to write down the equivalence, which is 1 slug is equal to 14.59 kilograms, and 1 meter is equal to 3.281 feet. Remember that this unit conversion, you can always do it on Google, right? Because I am doing it here for those who don't understand it, or who are not used to manage that kind of unit conversions. But this is not the easiest way to do it. This is the way for you to understand it. Now I'm going to do it on the calculator. So 163.1083 times 14.59 divided by 3.281. Now the answer is 725.3124 kilograms multiplied by meters per square seconds, which is the same thing as having newtons. Now I've searched this for the solution on the solutionary document of this book, because I always compare my results with the solutionary of the book. Now I've noticed that they are not the same, but I can assure you that this solutionary has a mistake. Now I'm going to put it on, maybe give me a sec here. Alright, now you're watching the document. So this is a problem 12.26. A person weighs 800 newtons. Is the same exercise, but the difference is the unit system. But at the end, they should have the same result that I get in newtons, because they are managing international system units here. But the result was this one, 262. Although the equation is correct, they have made a mistake with this part of the equation, because 6,372 divided by 6,372 plus 322 to the second power is not equal to 0.95. Is equal to 0.90, I think, 90 and some other numbers. Now I wanna make this clear for you because I know that some of you actually are not checking out the result that I'm getting, and they are checking out the result of the solutionary, the solution book for these exercises. So that's it. And this, guys, is how you could this exercise could be solved.